Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss measurement of the conductivity of ionic solutions. Last class I have discussed conductivity or conductance of electrolytic solutions. Last class I have discussed. Now I am going to discuss how it will be measured, how conductance will be measured. Then here to measure conductivity or conductance, we have to know something basic things, then quickly you can understand. Okay, measurement of conductivity of ionic solutions. Here what is the important things, that formula we know, I have already discussed that R is equal to rho into L upon A, where R is equal to resistance, rho is equal to rho that is a resistivity, and rho is equal to 1 upon kappa, means kappa, that is a conductivity. Then R is equal to rho into L upon A, where rho is equal to 1 upon kappa, that is the conductivity. Kappa means conductivity. Then here in this two term, R is equal to rho into L upon A. Here two terms are there. In that R is equal to rho into L upon A. Then rho and LA, separate term is there. L upon A is called cell constant. L upon A is called cell constant. L you know, L is the length of the solution. Suppose you have taken in a conductivity cell, solution is taken. What was its length? What was its cross sectional area? Then A is equal to cross sectional area, L is equal to length, and rho is equal to a resistivity, but rho is equal to 1 upon K, inversely proportional. Rho is inversely proportional to K. K means a kappa, that is the conductivity. Then here if you want to measure this conductivity, then you have to know two values. Means now you are putting the value of rho is equal to 1 upon kappa, hence R will be equal to 1 upon kappa into A. Just you have put the value of rho, then it became now L divided by kappa into A, capital A. Then now four terms are there, R, L, K and A. Then how you suppose if you want to know the value of K, then you should know the value of L, length of solution, A, cross sectional area, and R, resistance. Then here what is the problem, that L and A, it is a little difficult to measure. Always you have to measure the length, and always you have to measure the cross sectional area. Then it is somewhat impractical, not practical. It is little difficult. Hence what is a easy task? Then in indirect way we should know the value of L upon A, that is the cell constant. It is represented by G star. G is the conductivity. G is the this 1 upper long conductance. What are you telling? Conductance. Then here G is equal to 1 upon R. That is the, you can say, conductance. And kappa is conductivity. Then now if we will know the value of R, and actually we want to calculate LYA, cell constant indirectly, not by measuring the length of solution or cross sectional area of solution, not like this. Directly L upon A value we want to know. Then what problem will come here? Then you should know, you can say, two value, R and rho. If R is equal to rho into L upon A, then in this situation you want to know the this thing's rho value, or if you put the rho value of rho means 1 upon kappa, then R is equal to 1 upon kappa into A. Then here L by A directly you want to know the value of L upon A, that is the cell constant. Here one should know that for a cell constant value is constant. Once you will know the value of L upon A, then for that cell it is fixed. It will not change with the time. This is the plus point. L upon A, once you will measured, then this is called cell constant, G star, capital G star, and only G means conductance. G is equal to 1 upon R, that you know. Then here, once you will know the value of cell constant, then its value will be fixed for that cell. Its value will not change with time. Then it is a plus point that L upon A value, that is cell constant value, we should know. Then how we will calculate? Then here to calculate L upon A, then two terms are there after that, R and kappa. Out of 4 terms, 2 terms L upon A directly want to know. Then you should know R value and kappa value. Kappa, that is the conductivity. Then how will you calculate R value? R value, if you want to calculate R value resistance of the solution, then kappa value should know. Without kappa means this conductivity, that is also earlier it was known as a specific conductance. Then this value, specific conductance or conductivity, nowadays it is called conductivity. That value you should know. Only then R value you can determine. If L and A you want to know, that is a cell constant, then true value you should know, R value or kappa value. Then here I want to tell you, easily you will understand without any problem. It is a long, but I am telling you main things. Easily you can understand main things I am going to tell. Then here R and kappa, both values you want to know to determine L upon A. Then here actually by this method, in case of this measurement of the conductivity of ionic solution, here you will use Wheatstone bridge. Why Wheatstone bridge? Then here actually you want to determine resistance of the solution. R value you want to determine. Why not kappa? If both you want, both two values you want, R and kappa, why you selected R value? Why not kappa? Then here you should understand kappa value, that is the conductivity or a specific resistance, that is for some solution it is known, it is well known. Rho value, this value, kappa value for some solution like KCl, potassium chloride, it is well known at different temperature, at different concentration, what is its value, it is well known. Okay, for if KCl solution is 1, then its value is fixed. Suppose at 25 degree, at 26 degree, 27 degree, 28, 29, 30, 31, it will go up to 35 degree. Then its value is known. For every temperature 25 onward, its value is known with concentration. If 1 m solution is there, then what will be the value of this conductance? If 0.1, if 0.01, 0.001, then its value is fixed. That value you are knowing. Then here, if now you can tell if kappa value is known for a particular solution and a standard value you are knowing, then 3 things now you are knowing. 3 things now you are knowing. Okay. Then here one question you can ask that this if it is known, if a standard solution kappa value is known, then what is the need for this determination of R? When our intention is to measure finally, after knowing the R value, we want to know the conductance. We want to know the conductance. 1 upon R is equal to conductance. You will come to know the R value, you can know the conductance. Correct? And these things, kappa value, then why we need to calculate all the things? Kappa, conductance you are knowing, 1 upon R value you will come to know. Correct? Then conductance you will come to know. But here you want to know conductivity. You want to know conductivity, K value. For other solution whose value you are not knowing, only for one standard like KCl, only that, for that solution only you are knowing, not for other solution. Then suppose you want to know the, you can say this conductivity of other solution like NaCl, MgSO4, calcium chloride, many salt solutions are there. Then in that situation what you will do? But then for that purpose R value you are calculating, because in the beginning with the help of KCl you can know the value of R. One time KCl standard solution, its conductivity is known. It is known. Then first time with the help of KCl solution, that value you will use, and then R value you can determine. And once R value you are determining, then what will happen? R value you are knowing. Then now with the help of this formula only, kappa value you can determine. Because now R is equal to 1 upon L upon kappa into A. Then now this R value, suppose you are knowing, in the beginning K value for the KCl, kappa value are knowing. Then 3 value, then here you can say kappa value are knowing, L upon A you want to calculate, and R you are also knowing with the experiment. Now I will tell you how will it determine the R. But here R value and kappa value both you are knowing. R you will come to know by Wheatstone Stonebridge, and kappa from the chart, standard chart, you will come to know. Then L upon A value you will come to know very easily. That is the cell constant. Then now once you are knowing the value of cell constant, that's enough, its value is fixed. Then now after that, in the second step, if L upon A value now you are knowing, cell constant value you are knowing, then now R value also you are knowing. Suppose second time for unknown solution, now suppose MgSO4, magnesium sulfate solution, now you want to know the conductivity. Then now at this situation, what you will do? kappa value is not known, you have to calculate conductivity for MgSO4 or NaCl for any salt. Then now cell constant value you are knowing, cell constant value you are knowing, and kappa value you want to calculate. Then R value again you have to calculate for that solution, because R value will vary for different solution. R value will vary according to the solution. If NaCl solution is there, then for that solution R value will be different. If other like can say other K2SO4 solution is there, potassium sulfate, then their R value will be different. MgSO4 is there, R value will be different, but cell constant value will be fixed. Then now cell constant value you are knowing, kappa value you want to calculate, kappa value you want to calculate, conductivity you want to calculate, not conductance, not 1 upon R. Conductivity value you want to calculate, kappa. Then R value, at every time R value of the solution you have to calculate, correct? Because first time with the help of KCl solution, you came to know L upon A value, means cell constant. Now once you are knowing the cell constant, then in second second experiment, you will use this cell constant value, and again you will determine R value for any particular electrolyte, as for example potassium sulfate or magnesium sulfate or sodium chloride, any solution, correct? Then for that solution, what is the R value? In second time you have to determine, 2 time experiment you have to do. First to get the cell value, cell constant value, and second again R value you calculate for the new solution, correct? KCl you have used only for to get the value of L upon A, means cell constant. I think now this difference you understood. Now cell constant value you are knowing, then you will repeat the experiment with the another solution, unknown solution. Then for that solution again R value you have to calculate with the Wheatstone bridge, okay? Then now I will tell you Wheatstone bridge how we will calculate, but nowadays in the place of Wheatstone bridge, conductivity meter is available. In the beginning Wheatstone bridge was used, and it was actually complicated. It is complicated. Wire connection is more. 4 resistance wire you will use, okay? Then that was very complicated. Earlier in our time this Wheatstone bridge was there. It was very difficult to make a connection, but nowadays direct conductivity meter is available. You can know the conductivity, but here you have to know how will you use the Wheatstone bridge, because inside the conductivity meter same arrangement is there, same arrangement what is in Wheatstone bridge, same connection. Then now I am going to tell you how will you measure the, you can say, resistance of the solution with the help of Wheatstone bridge. Then here this a very simple way I am telling you. It is complicated, but main things I am telling you, you will I think you will understand very quickly. In Wheatstone bridge, 4 resistance wire is used, okay? 4 wires will be there, means that is out of 4, 3 wide resistance will be well known. 4 wires different of 4 wires of different resistance is required, but one you leave it. 3 out of 4, 3 you are knowing, 3 wire you have taken and their resistance value you are knowing, for resistance 1, for resistance 2, for resistance 3. Out of 4 any 3 you are knowing, that that you just keep in mind. Out of 4, 3 wire resistance you are knowing. Every wire has different resistance. As for example, R1. Suppose R1 is unknown, 4th one will be unknown. Then 3R will be known. As for example, R1, R3 and R4. 3 wires are there. All are connected. And these are connected, and they are connect. And fourth one will be unknown solution, whose fourth one will be unknown. Okay, whose unknown solution, that is the conductivity is in conductivity cell. That solution you will take. Okay, that solution, that unknown solution whose conductivity you R value, whose conductance you want to know, not conductance, whose resistance you want to know, that will be fourth one, unknown solution, its resistance you want to know. Correct? Then these total 4, one is unknown solution, its resistance you want to know. That is taken in conductivity cell. Okay, last class I have sent a diagram for conductivity cell. Today also I will try. Then now this 4 connection, these 4 connections actually are done in a these things parallelogram, like that, parallelogram. Okay, all 4 connection will be in parallelogram, you can tell. Then now suppose one wire is known wire, suppose it is the R1, R2 is unknown solution consider as a R2, and after that R3 and R4. Okay, then here one more things will be connected, that is the detector. Headphone means P, you can tell, P, one connection is made, that is called suitable detector. Okay, suitable detector, also called headphone. And this is actually electronic device. This is electronic device, headphone. It means you can listen. Sound will come that you can listen. That is a headphone. Then that will be connected also. Then now what will happen? Suppose this P1, P2 is suppose not P1, R1 and R2. Then R1 is the resistance, R2 that is the unknown solution, R3 one wire is there, and R4 other wire is there. Then now that R1 and R4 in parallel, R1 and R4 resistance is in parallel, and now what is remaining? R2 and R3 is in parallel. Correct? R1 and R4 is in parallel, and R2 and R3 is in parallel. This you know, this is very, very important. Correct? R1 and R4. R1 and R4 is in parallel. Then what is remaining? R2 and R3. In that R2 is unknown. Then these 4 wires are just like in a parallelogram, like just like that a structure is there, which is and these wires are connected through headphone detector. Okay, sound detector you can tell, telephone as a headphone you can tell. This is actually electronic device. Then now what will happen here? This structure I have told you. Okay. Then now what will happen? If you can say this, if experiment will start, then what will happen? Means now current is flowing. Suppose current is flowing. Then what will happen when equilibrium will come? At equilibrium position means it is just become just like this connection is known as a bridge. Then if you can say if bridge is balanced, when main things I am telling you, that when a bridge is balanced, then no current passes through the detector. Otherwise current will pass through detector, means P. But if it is balanced, then no current will pass through detector. And under this situation, product of resistance, actually in this situation headphone, you will put headphone, then in the beginning some sound will come. Actually it is a wire, I told you wire is there on a long wood. One wire will be there. On that wire, just like a scale, it will be marked 0 to 100. 0 to 100 centimeter, 1 meter you can tell, 0, 1, 2, 3, 4, 5 like that, mark will be there up to 100, correct? And again from one end 0 to 100, and from the other end 100, you can say it will start from 0 to 100 this side. Suppose in the beginning two wire, this wire is there, then one is starting from 0 to 100, and other will be like that other end 0 and left hand 100. Means in the beginning left to right 0 to 100, and again right to left 0 to 100, opposite direction. Two mark will be there. Once it will start from 0 to 100, like 1, 2, 3, 4, 5, 6 like that, 0 to 100, left to right, again right to left, then 0 to it will start 0 from right and it will 100, it will come to the left, opposite. Two mark will be there. Okay, then there one jockey will be there. Jockey, that will be joined by headphone. Then that jockey, you have to touch the, you can say that wire, that conducting wire will be there. That wire you have to touch it. Then in the beginning some sound will come, and again slowly sound will decrease. Finally it will stop, no sound. That is called null point, NULL, null point. No sound will come. That point mark you note down at what position it has come. Then suppose 56. At 56 mark means 56 centimeter. I mean when it reached, we are just moving, jockey we are moving. Then at 56 mark, now no sound you are feeling, no sound comes. It means this bridge is balanced. This bridge is, Wheatstone bridge is balanced, no current is flowing. Null sound, no sound is coming, null point means in this situation no current is flowing, means it is balanced, because connection is like that, it will balance. Okay, then that point you have to note down. What is the point? Then suppose it was 56, then 100 minus 56 is the from the other end 56, then 44 is remaining. Then two value you are knowing, and third value, these two value by experiment you are knowing. By experiment these two values you are knowing, and third value, that value also you will come to know. R1 value will come to know, already it is known, well known. Then now three values you are knowing. Fourth one is unknown solution, correct? then all 4 value, actually unknown solution also you are knowing. Means by experiment you are going to calculate. When it bridge become balanced at null point, you have noted down the 2 values. Like for example 56 and 44, and one already you are knowing. You have removed the rested box will be there. From that known resistance you have removed, then current was flowing. Then 3 value, and fourth one is I can say unknown solution. Then actually at this situation what will happen when it become balanced, that now both resistance and opposite R1 and R1 into R4 became equal to R2 into R3 at balanced point. This is important. R1 parallel, R1 into R4, both were in parallel. That became equal to R2 into R3. R1 into R4 equal to R2 into R3. Then here R2 is the unknown solution, their resistance. That R2 value you are knowing, all 3 value you are knowing. R1 value, R4 value, correct? R3 value, 3 value you are knowing, then R2 you can calculate very easily, correct? Means R1 into R4 divided by R3. You will balance it. Automatically you will write that R2 into R3 is equal to R1 into R4. Then what is the value for R2? Unknown. Then R2 is equal to R1 into R4 divided by R3. Now by experiment all value you are knowing. Unknown value, that is the R2, now you are knowing by experiment, correct? Then R2 value you are knowing, means resistance of unknown solution you are knowing. And now your problem is solved, because cell constant value quickly will come to know, because R is equal to these things L divided by kappa into A. This is the relation. R is equal to L divided by kappa into A. Then you wanted to know L upon A, correct? And kappa value, what solution you have used in the beginning, first time you are doing this experiment, then suppose that value you were knowing, that this value, its value will be fixed. Because you have taken the known solution, standard, then that value you will come to know. Then that value you put these things kappa or rho, whatever you can tell. Kappa you remember only one value you have put, then R value, capital R value you are knowing. Then now you will come to know the L upon A value you are knowing, because R and kappa both value you are knowing. Then L upon A value, cell constant value you are knowing. Your experiment is over. Now unknown solution you will take, as for example NaCl solution. NaCl, its value you are not knowing. Then now this experiment again second time you have to do, but this time cell constant value you are knowing, and R value will determine for this solution by following the same experiment. Then R value will come to know, cell constant value you are knowing, then you will know the what you will come to know, then kappa value will calculate very easily. Okay, kappa value you will calculate very easily, because cell constant value you are knowing, R value you are knowing. Then 1 upon K value you can calculate very easily, or kappa value easily. Then this is the main things of these things we test on bridge. And I want to tell you that 1 to value that standard standard value of KCl solution. At you can say this value is at 298 Kelvin, 298.15 Kelvin means 25 degrees centigrade. In Kelvin, 273 plus 25, 298. Exact is 298.15 Kelvin. Then at that temperature, KCl value I am telling you, for 1 mole per liter, if concentration is 1 KCl solution concentration is 1 mole per liter, that 1 mole per liter means you multiply by 1000, then it will convert into, you can say, molarity. 1000 times you have to multiply simply if you want to convert into molarity. 1000 times. Remember, in making numericals this simulation will be useful. Then suppose now 1 mole per liter. 1 mole per liter is the concentration. For that concentration, its conductivity in Simon per centimeter. Unit, you know, unit is Simon per centimeter. This is the unit for conductivity. Then its value is 0.11. Conductivity value for 1 mole per liter KCl solution. Its value is 0.111. 111. I can say exact, actually here we should know the exact value. Then 0.11113 0.1113 Simon per centimeter. If now concentration is decreasing, now suppose concentration decrease 0.1 means 0.1, then 10 times decrease, it was 1, now it became 0.1, 0.100 or 0.1. Then now if you want to know in the terms of molarity, then 0.1 into 1000, then 100, then it will become 100, and molarity is 100. Then for this situation conductivity when concentration is 0.1, that time now conductivity decreased 0.0129 0.0129. Now suppose further concentration decreased, means now it became 0.01, 100 times decreased, 0.01. 1 was there, 1 became 0.1, now again it became 0.01. Then in comparison to the first one, it is 100 times decreased. Then now if you want to know molarity, then multiply by 1000. Then 0.01 into 1000, it will become 10. Then in that situation, conductivity will be further, it is decreasing. Its value is 0.00141. Actually, I will tell you why does it happen. Okay, but here you know, if concentration decreases, molarity, conductivity also decreases. Already I told you, when this concentration is more, then more ions will be there. That's why conductance will be more. If this concentration is less, then less number ion will be there. Then conductivity will be less, because these are the charge carrier. Only these ions are carrying the charge, that their number is decreasing. Then conductivity will decrease. Very simple way. But in that also one exception is there. I will tell you that we will tell you next class. But here I am telling you that with concern in general way, if concentration is decreasing, then this will decrease. Conductivity will decrease. With the decrease of concentration, conductivity decreases in a general. But exception I will tell you, which is asked in examination, I will tell you. Then now I have told you that how to calculate the conductivity. Then first cell constant, that is the first step. Second step, again experiment you will repeat. This time cell constant value you are knowing, and you can say R value of the unknown solution like NaCl, MgCl2, you will come to know by the experiment. Then I can say solution resistance value will come to no, because that formula you are knowing. Formula now you are knowing that R1 into R4 is equal to R2 into R3. On that formula again you will use and you will calculate the R value. Then now R value you are knowing. Then now this formula R is equal to L upon kappa into A. Then here L upon A value you are knowing, then only kappa value you have to know. Easily you can calculate. This is very, very important things I have discussed now. Okay. And other things already I have told you. One relation is there that you should know, because when you will go in the lab to do the experiment, then that time this value will be useful, and that is easy to understand. Okay. I already told you that you have to multiply by 1000 mole per liter. You want to convert into the molarity, you have to multiply by 1000. That you are knowing. Then 1 Simon meter square per mole. Correct? This relation actually this is for unit for conductivity. Okay. This is the unit of conductivity. Then how will you can say this is actually molar conductivity, what I told you. Then 1 Simon meter square per mole. That is equal to, if you want to convert this meter square into you can say centimeter square. Meter square, now you want to convert into centimeter square. 1 Simon meter square per mole. Now you want to calculate Simon centimeter square per mole. Means simply meter square you wanted to convert to centimeter square. Then you know 1 meter is equal to 100 centimeter. Then simply you have to multiply by 10 to the power 4. Correct? 1 meter now it will convert to 10 to the power 4. Correct? 100 into 100. 1 meter is equal to 100 centimeter, and it is a square. Meter square. Then 100 square means 10 to the power 4. Then this is the relation, that 1 ohm, not 1 Simon meter square per mole. That is equal to same things, only 10 to the power 4 you have to use. Then 1 Simon meter square per mole is equal to 10 to the power 4 Simon centimeter square per mole. Very simple. Then this relation, by use of this relation, one more relation you can calculate very easily. When 1 Simon meter square per mole is equal to 10 to the power 4 Simon centimeter square per mole. That now you have done. Then if suppose you are knowing the value of this thing in centimeter square per mole, you are knowing the value, and you want to convert it into mole, meter square. Then now same formula, 10 to the power 4 Simon centimeter square per mole is equal to 1 Simon meter square per mole. Then for 1 Simon centimeter per mole is equal to what? Now we are knowing for 10 to the power 4. 10 to the power 4 is equal to 1 Simon meter square per mole. Then for 1 centimeter, 10 to the power 4 for the 4 value is equal to 1. Then for 1 upon 10 to the power 4. 1 divided by 10 to the power 4 means 10 to the power minus 4. That is, now this you converted, centimeter converted into meter. First time you converted meter into centimeter. Centimeter square. Meter square you converted into centimeter square. if you are knowing value in centimeter square and if you want to calculate in meter square, then nothing, only 10 to the power 4 was there, it will reverse. 1 upon 10 to the power 4, that is a 10 to the power minus 4. 10 to the power minus 4 means 1 Simon centimeter square per mole is equal to 10 to the power minus 4 Simon meter square per mole. Okay, this actually it is very complicated things. I think now this all things you have understood. In real sense it is complicated, but I have discussed. I think now you have understood this relation also. It is complicated, but finally I told you how to know the relation, how to convert meter square into centimeter square into meter square, because in numericals this relation is useful. Okay, then I have discussed about the this things, Wheatstone bridge, measurement of conductivity of the ionic solution. Now one numerical is there that I want to discuss. Actually now because you are knowing all the things, then this will be easy for you to solve it. You can solve it also, but I am telling you all numericals based on electrochemistry is coming under difficult, but it is difficult only for those who are not understanding. But you are understanding, hence it will be not difficult for you, and easily in examination you can solve it. Only you have to understand the question, and in a cool mind you remember the formula and you can solve it. Actually one relation is there that always you keep in mind. Molar conductivity, a sign is lambda m. Lambda just like a reverse of V. V you are in U V. Then reverse of V and down a small m you write. That is called lambda. Lambda m means molar conductivity. Then molar conductivity is equal to what? Kappa upon C. So it is also conductivity only. Conductivity only name is molar conductivity. You have to give the importance for concentration. In molar, you know, that is a mole per liter. Molarity, mole per liter. Then that is a concentration actually. Mole per liter, that is a concentration. In general way you can tell like that. Concentration is equal to mole per liter, it is common. Then here kappa, conductivity, you divide by this concentration. Concentration means here you will take molarity. Means simply you can tell kappa upon C. Kappa upon C means concentration. That is called molar conductivity. This relation don't forget. If kappa you are knowing and what was the concentration, if you are knowing concentration of the solution, just to divide it kappa upon C, then you will get molar conductivity. That is called this thing, symbol is lambda m. Lambda m. Okay, now question I am reading, you can solve it. I think after understanding easily you can solve it. Okay, I am reading the question, then you can understand it. This resistance of a conductivity cell filled with 0.1 mole per liter KCl solution is 100 ohm. 100 ohm. If the resistance of the same cell when filled with 0.02 mole per liter KCl solution is 520 ohm, calculate the conductivity and molar conductivity of 0.02 mole per liter KCl solution. The conductivity of 0.1 mole per liter KCl solution is 1.29 Simon per meter. Okay. This is a question. Again, one more time I am reading. Resistance of a conductivity cell. Listen carefully. Resistance of a conductivity cell filled with 0.1 mole per liter KCl solution. Correct? KCl solution concentration is given. And after that, this resistance of conductivity cell filled with 0.1 mole per liter KCl solution is 100 ohm. R value they have given, unknown, not known, for known, 100 ohm it is given. If the resistance of the same cell when filled with 0.02 mole per liter KCl solution is 520 ohm, two values of ohm they have given. Calculate the conductivity and molar conductivity of 0.02 mole per liter KCl solution. Means the concentration only it is changing. And value they have given, conductivity of 0.1 mole per liter KCl solution is 1.29 Simon per meter. Means here total three solution they have given. First solution is this thing filled in conductivity cell. Its concentration is 0.1 mole per liter KCl solution. All are KCl solution only. Then first in conductivity solution, when its concentration was 0.1 mole per liter, that time resistance was 100 ohm. Second, again they have given, if resistance of the same cell when filled with 0.02 mole per liter KCl solution, again KCl solution is there, but now concentration has changed. In the beginning it was 0.1, now it is 0.02. 0.02 mole per liter when they have filled, then KCl solution, then that time its resistance was 520 ohm. Means in the beginning it was 100. When now concentration changed, then resistance changed. Now it became 520 ohm with second solution, means 0.02 mole per liter. Now third things they are asking, calculate the conductivity and molar conductivity of 0.02 mole per liter KCl solution. Means second solution, their conductivity they are asking. So second solution when concentration was 0.02 mole per liter, its conductivity they are asking. Okay, and what they have given, the conductivity of 0.1 mole per liter KCl solution, means for the first solution, their conductivity they have given. Already I told you, standard. The conductivity of 0.1 mole per liter KCl solution is 1.29 Simon per meter. Correct? From the chart that value is given for 0.1. For 0.1 all thing is given. For 0.02 you have to calculate. Very simple things. I have told you 2 experiments you have to do. Then first experiment you will do to get the value of cell constant. First experiment. For that you can say they have given the value, conductivity value they have given. Correct? And then from the first experiment you will get the value cell constant, and after that second experiment, for that they have given 0.02 mole per liter. Means the KCl solution is there, but now concentration is different. Then for that they are asking conductivity. Means you have to do second experiment. Then it means from the data, first data I will calculate cell constant. And now when cell constant you are knowing, Then kappa you can calculate very easily, because for the second experiment resistant value for 0.02 it is given 520 ohm it is given. Then I think now you are understanding what you have to do. Then here first you have to calculate, you can say these things, cell constant. You have to calculate cell constant, that is a G star, capital G star, that is its this thing symbol G star. Then G star cell constant is equal to, now you know, conductivity into resistance by the formula, because conductivity is equal to what? Cell constant divided by resistance. Correct? Means R is equal to L divided by kappa into A. Then L upon A is the cell constant. Then it will get this relation only. That is the cell constant is equal to conductivity into resistance. Okay, easy. Just only just you have to arrange it. You will get this relation. Cell constant is equal to conductivity into resistance, or conductivity is equal to cell constant divided by resistance. This is the formula. Okay. Then this easily you can relation you can remember also. Then now this cell constant values they have given in question 1.29. Then 1.29 is equal to conductivity. Conductivity, actually this Simon per meter is there. You can convert into centimeter also. Meter, Simon per meter is there. If you want to calculate in centimeter, then you have to multiply by 100. Okay, or you can tell these things that you have to calculate in meter, then centimeter easily you can convert. But here cell constant value first you have to calculate. Cell constant value. Then first you calculate the cell constant value. Then cell constant value is equal to conductivity into resistance. Then resistance value it is given in question for the first solution. First experiment we will do, in that 100 is there, it is given in question. Then 100 into 1.29 Simon per meter. Then 1.29 into 100 ohm it is given in question. Then you will get 129 per meter. 129 after multiplying you will get 129 per meter. That you can, per meter you can convert into the centimeter. That is the, you have to divide, meter is there, then you will get 1.29 per centimeter, divide by 100. Okay, because meter you are converting into centimeter, formula you are knowing. Then 129 per meter means 1.29 per centimeter. Okay, then now cell constant value you are knowing. Then if you are knowing the cell constant value, then now second experiment we will do. Then conductivity of 0.2 mole per liter KCl solution. Again same things we have to do. Cell constant divided by resistance. Conductivity is equal to formula, same formula. Cell constant is equal to conductivity into resistance. Then conductivity is equal to cell constant divided by resistance. That formula now you are using. Then cell constant value 1.29 you are knowing, and resistance for the second experiment they have given 520 for the second solution, 520 ohm. Then 129 divided by 520, then you will get 0.248 Simon per meter. If you want to keep per meter only, then don't convert into centimeter, not required. Correct? Then now you got this value. Conductivity what was in question you have, now you got the answer. Conductivity that you got. Okay, conductivity of 0.02 mole per liter, that now it became 129 divided by 520, 129 per meter divided by 520 ohm. Hence result you will get 0.248 Simon per meter. Okay. Now you can say if you molar conductivity also you have to calculate. Conductivity you have to calculate. Okay. Then conductivity you have calculated. But molar conductivity of 0.1 mole per liter that is actually given. Then now you have to actually, in according to the question, you were supposed to calculate conductivity and molar conductivity. Then conductivity you have calculated. Then molar conductivity formula you know, molar conductivity is equal to kappa divided by concentration. Then kappa value now you are knowing. Kappa value now you are knowing, we have calculated 0.248 Simon per meter. Then concentration, how will you calculate the concentration? Then concentration, how will you calculate? Then concentration already given this things 0.02 mole per liter. You have to not calculate 0.02 mole per liter. It is given. Okay. Then here this things concentration is 0.0 mole per liter, 0.02 mole per liter. It is given. Then mole per liter is there. Then you can convert it into mole per liter is there. You can convert into the, you can say meter, cubic meter. Then for that you have to multiply by 1000. Multiply by 1000. If a per liter is there, then simply you multiply by 1000, because all relations are in meter. Hence you should know in terms of mole per cubic meter. M-3 you have to calculate. Then mole per liter is there, convert into the cubic meter just by multiplying 1000. Okay. Then actually this relation also you keep in mind, 10 into 10 into 10, 10 centimeter into 10 centimeter, 10 centimeter, 1000 centimeter cube, that is equal to 1 liter. Correct? And 1 cubic meter means also 100 into 100 into 100 centimeter, 100 centimeter into 100 centimeter into 100 centimeter. Then 2 into 2, 10 to the power 6, I can say centimeter cube will come. It means that is at 10 to the power 6, then 10 to the power 3 you are using, hence 10 to the power 3 will be remaining. That's why 1000 you are multiplying. 1 meter is equal to 100 centimeter. Then 100 centimeter into 100 centimeter, 100 centimeter, 1 cubic meter. Correct? Then if 10 into 10 into 10, 310 you are using, then 3 0 will be remaining. That's why you are converting into cubic meter, then you have to multiply further by 1000. Then now this value 0.02 mole per liter, it is given in question, you have converted into the, you can say cubic meter. Then 0.02 into 1000, you will get 20. After multiplying, you will get 20 mole cubic meter. After that, molar conductivity formula you are knowing. Molar conductivity means lambda m is equal to kappa into concentration. Then kappa value already you are knowing, 248. Actually that is in Simon per meter square. Simon 0.248, that also you can write 248 into 10 to the power minus 3. You can write 0.248, then 248 into 10 to the power minus 3 you can write. Then generally conductance is written like this way only, some power, 10 to the power some power. That's why it is, you can write 248 into 10 to the power minus 3 Simon per meter. Same things, only 10 to the power minus 3 written. Then this value, conductivity value, kappa value have written. divided by concentration, then concentration is 20 mole per cubic meter. Then now just to solve it, 248 divided by 20, then it will come, how much it will come? 20 is there, then why it will come 124 divided by 20, 248 upside, down 20, then 2 it will cancel down, upside 124, and 110 will be remaining down, that will go minus 1, it will increase, then 10 to the power 2, 10 to the power minus 3, that will become 10 to the power minus 4. Okay, because 2 into 10, if you write, then 2 and 248 upside, 124, then 10 is down, means 10 down is there, already upside 10 to the power minus 3 is there, then now it become 10 to the power minus 4 Simon meter square per mole. Okay, then this I have solved the one